Hi there, I'd like to thank everybody for the advice in terms of trying to get hold of some 48 DP cutters, and I've managed to get numbers 7 and 5 from RDG Tools, but numbers 4 and 8 still elude me. So I've put some feelers out on some other sort of channels really. See if I can get hold of some second-hand ones. Fingers crossed I'll be successful. And I'm really excited because I've never been to one of these before, but I've decided to, well, I've just bought a ticket for the Midlands Model Engineering Exhibition to be held at the Warwickshire Event Centre in October. So hopefully I'll get there for the Saturday. It takes 4.5 hours to get there on the train from here, so I think I'll stay over on the Saturday night, but I'm really looking forward to that. Anyway, in this video I'm going to be having a go at making the crankshaft housing for this Jerry Howell V-twin, and it'll fit on there. Now this housing is going to be made out of this lump of aluminium, and that will eventually fit onto there, and it's going to be machined to hold a couple of bearings which will be used to support the crankshaft. Well, I've been trying for ages trying to get this centred in the 4-jaw chuck, and I'm struggling, so I've just put it on here, and if I get that at right angles I can see that there's a big gap there. So I think what I'm going to do is I'm going to mark that with a felt tip pen and pack that under one of the jaws on the 4-jaw chuck, and then try and straighten it up. Well, that's the packing in there. It's fairly close. I'll move it out. Still fairly close, so I'm happy with that. Well, that's pretty close, and I'm not really bothered that it hasn't quite caught these edges here, because I'm going to reduce this down. So now I need to turn this outside diameter down to 2.7 of an inch. So now I need to reduce this down to a diameter of 2.125 for a depth of 0.373 of an inch. So I've set the depth stop, and we'll see how we get on. pretty good. Now there was a requirement to open a hole up right through 0.7 an inch in diameter, and I did that using a combination of drill bits and this boring bar. So now what I need to do is to open up another hole here to take a ball bearing race, and it's got to be 1.375 of an inch in diameter and 0.433 of an inch deep. So I'm going to open it up in about 10 thou increments. So I've set my caliper to the width of this bearing, and I'm looking for a transition fit, which this should be about 1 thou smaller. And it's about 2 thou smaller, so I just need to take another thou off. I can hold it right. Yeah, 2 thou. 1.5 thou. 1 thou. I'll just take a fraction off. Yeah, I think that'll be good. Bit of chatter on that. Yeah, I think that'll press in okay. And I'll just clean up the inside now. I went to a depth a few thou less than the final depth. So what I'll do is I'll go to the proper depth and then just withdraw the tool that way until I get to the right outside diameter. And there's also a requirement just to open the inside up a little bit more, where the inside of the race is, if that's what you call it, so that can turn freely without touching that part there. But I'll do that bit off camera. Well, so far so good. Shame about the chatter I got just in there, but I've reduce the length of the boring bar and replace the tip, so hopefully that won't occur next time. And I think that's a pretty good fit. I think it'll just press in there. There's hardly anything in it, 1 thou if that. But I won't press it in until after I've machined the other side. And it does fit well on here. Famous last words. So what I need to do now is to turn it over, put it in the 4-jaw chuck like that. I'll centre it on this edge here. it needs to be spot on, because I'm going to put another bearing in there, and obviously that's got to be dead centre with that one as well. So that's the plan. I don't think I can do better than that. So what I'll do is I'll reduce this down to this diameter here, and then I'll just face it off, and I'll do that off camera and then I'll get back to you. Well, I was starting to worry because I can't get the caliper in here to measure the width, and the total width needs to be 1.410. But I do know, assuming I've machined this correctly, that should be 0.373. So I've measured this bit with the caliper, and that comes in at 1.092. So if I add 0.373 onto that, I get 1.465. Now the target width is 1.410, so that means 55 thou's got to come off this face here. 55 thou equates to 1.397 millimeters, so that's one full turn of the compound slide plus 19.85 increments. So for this type of machining, I do tend to lock the carriage, so eliminate any movement on the carriage, and then I just use the dial on the compound slide to move the tool in to the appropriate distance. So I'll be cutting in about 10 thou increments. So I'm getting close to the target width now, so what I'm going to do is I'm going to use a fine feed on the cross slide, and then I'll take a measurement. Well, that's coming in at 1.0425, and it should be 1.037, so that's 5.5 thou to go, which equates to 0.1397 millimeters, which is 7 increments on the compound slide dial. So I'll finish it off camera and then I'll get back to you. So now I need to open this up to accommodate that bearing. Now the bearing is 1.125 in diameter. This is currently measuring 0.715 of an inch, so that's 0.410, which equates to, well, you divide it by 2, 0.205, which is 5.2 millimeters. And I've set the depth stop to 0.3 of an inch. The target is 0.312, but I'll finish the far inside once I've got the outside dimension correct. So just use the fine feed there to measure it. Okay, so this measures at the moment 1.117 of an inch, and my target is 1 thou less than 1.125, which is 1.124. So that's the difference of 7 thou divided by 2, 3.5 thou, which is let me see, 0.089 of a millimetre, so about just over 4 increments of the dial. So I'll go 3 initially. I'll use the fine feed. It's getting close, so I'll continue with that method until I'm just about 1 thou under. Well, that feels pretty good. I think that'll be a nice press fit. So what I need to do now is to turn this outside diameter down. I'll start doing it off camera. I think I might have a bit of a problem getting in here, but I'll see how I get on, and then I'll get back to you later on once I've done some of the machining. Well, I've just remembered I haven't actually finished this inside off. So it's currently, the depth of this is currently 0.3 of an inch, and it needs to be, let me see, 0.312. So I've set the depth stop, and I just need to clean that inside face up. Well, this method seems to be working reasonably well. Well, that seems to turn out okay. So what I need to do now is to go over to the mill and use the bolt circle function to drill some holes to match these, so it can be bolted on the frame like that. And there's also a requirement to cut a little keyway in here to allow oil to flow sort of past the bearing. So for the bolt circle function, you just hit that. It's on the XY plane. The centre position is on the 0 coordinates. The bolt circle diameter is 2.43 of an inch, which is what's that there. Starting angle 0 degrees. That's actually 3 o'clock position. Don't know why it does it like that, but anyway, I suppose it's because it's on the x-axis. And the end angle I've put as 360 degrees, and that'll become clear on the next one. Because I'm saying there's 7 holes. There are actually 6 holes to be drilled. But I always add 1 to the number of holes to give, in this example, 7. And tell it to finish on the hole that it started on, if that makes sense. And then it tells me the coordinates of the first hole, so I just move the tables to those coordinates, so get to 0, centre drill, and then drill through. Having done that, I'll then move to hole number 2, just move the table accordingly to the 0 position, and centre drill, and drill through again. So I'll do all that off camera, because it's just centre drilling and drilling really. But once I've done that, I'll get back to you. So I've switched the part around, and I need to cut this slot for the oil way, and I should be using 5/32 of an inch end mill, but I've not got one of those, so I'm using the 3/16. Well, I very nearly messed up here, because I was thinking initially about drilling the holes from this side, which you can see some marks here with a little centre drill, and then I realised that there was a requirement to countersink as well, so I drilled through from this side, but I think it's turned out alright. The acid test will be as to whether or not the bearings line up. So I'll just go over to the press and press them in, and then I'll get back to you. Well, this is a piece of silver steel, and it looks like I've got a result. That's a relief. You can see that oil way in there. Looking good. Well, I must say I'm really happy with that result. I'm over the moon with it. Major relief that those bearings lined up, because I don't think there's any way you can press them out again once they're in. But anyway, it does seem to work okay. So very happy with that. So I hope you enjoyed this video, and I hope to see you later.